loca, loca, vanitosa.
Yeah, you know what to do. Hey, Mr. DJ.
Motion transfer and character replacement have always been the most popular use cases in AI/GC video generation. After all, who wouldn't want to use different characters to dance the latest trending hand gesture dance, imitate classic movie clips, or even pull off a fight scene? SCAIL-2 is currently the strongest open-source solution in this field. It was jointly open-sourced by Zhipu AI, the team behind the open-source GLM model, and Tsinghua University. Its core technologies include in-context mask conditioning, mode-specific shifted rope, and bias-aware DPO. I won't dive into the details. The official claim is that SCAIL-2 beats the previous king, WanAnimate, in single-character animation, multi-character animation, and character replacement, and in some scenarios it approaches the closed-source commercial model Kling 3.0. I've done a lot of testing in my local Comfy UI recently. Even with just the most basic official workflow, the results are quite good. If you tweak the flow and pair it with looping to extend the video, you can crank out a several-minute-long video in one go, with no jarring hard cuts. In today's video, we'll start with the model download and environment setup. Then, building on the simplest workflow, we'll walk through the details and finally use a looping workflow to finish a minute-scale re-render. We'll also cover parameter intros, a comparison of motion transfer versus character replacement, demos across different scenarios like single-person and multi-person, recommendations for handy third-party plugins, and a final summary of the model. There's a lot to cover, so let's get started. First up, of course, is downloading the model. As I mentioned in the Ideogram 4 tutorial last time, if you want to use a model natively in Comfy UI, the easiest way is to go straight to the Comfy.org official repo. The Diffusion Models folder there has 5 different quantized formats. Meanwhile, the SCAIL-2 official repo from Zhipu AI only has a 65.6 GB PT model, which isn't the common SafeTensors format, so it's hard to use directly. Among the formats Comfy.org offers, FP16 has the best theoretical quality, but it's also the largest file. Without 24 GB of VRAM, you generally can't run it. int8, FP8 glazed, MXFP8, and NVFP4 MXPF8 mix are all different derivative versions, and the ones with the MX tag are only suited for 50 series NVIDIA cards. int8 convert or convolution rotation int8 is a format newly natively supported by Comfy UI, and it supports 20 series and above NVIDIA cards with the Turing architecture. This format is theoretically great value. The community's ranking goes like this, and if you're on the latest Comfy UI, you can give this new format a try. The DPO LoRa is a quality enhancement LoRa officially released for SCAIL-2, and you can grab a version here that works directly in Comfy UI. The workflow also uses the Light X2V acceleration LoRa, which we use a lot with the WAN series of models. You can find it in Kijai's repo. Just make sure to pick the one made for the WAN 2.1 model. Real Rebelized GGUF quantized version of SCAIL-2 has a fair number of downloads. Generally, if you want better quality, go with Q8A0. If you want value for money, Q6K works, and I don't recommend using anything below Q4. SCAIL-2 depends on a matting model to create masks for the reference image and the driving video. The common choice is SAM 3.1 or Segment Anything 3.1. Dig around in the Comfy.org repo and grab the multiplex version. On top of those, there are a few more WAN 2.1 related dependency models. For example, the text encoder is OMT5XXL, the clip vision encoder is ClipH, and the VAE is the WAN 2.1 VA, all familiar faces. Each model goes into its corresponding spot, as shown in this table. Now let's start Comfy UI and check the version first. I'm on the latest core build, version 0.27.0, with the template library at 0.11y. By the way, after updating the Comfy UI core, it's best to update the dependency libraries at the same time. The front-end and template library being a bit behind is fine, but a mismatch in libraries like Amido can cause startup failures or runtime errors. Open the template library and search for Scale. The workflow in the top left is the official example. Although the workflow name says character replacement, it actually supports both modes. You can switch it to motion transfer mode with a single option. Load this workflow. It's the familiar subgraph version. The top right shows 12 errors, but 5 of them are missing models, and the rest are missing the reference image and driving video. That's the biggest advantage of the official workflow. It might not deliver peak performance or quality, but because it sticks to native nodes as much as possible, you don't need to install any plugins, which makes it very friendly for beginners. The node in the top left is for loading the driving video. I'll swap in a hand gesture dance clip from Ode to Joy. It's got a crisp rhythm and rich hand movements, which makes it great for testing motion following. This native video loading node is a bit awkward to use. After picking a video, you can't shrink the node, so it covers up the nodes below it. I'll nudge it up a bit. Upload an image of a girl in an ancient-style fox costume as the reference image. Since this flow takes both a driving video and a reference image, the model already gets a lot of information, so the prompt can be a bit simpler. I'll just write "a girl is dancing." There are 2 subgraph nodes in this workflow, set up to demo the 2 modes, regular generation and extension. I'll explain the difference later, but all of that is hidden inside the subgraphs. So to actually use it, you just keep the parameters in both nodes the same. The replacement mode option controls the mode when it's on. It's character replacement. We'll turn it off and start with motion transfer to demo the flow. Resolution 512 by 896, 81 frames, turbo mode. Then set the SCAIL-2 model, the Light X2V acceleration LoRa, the DPO quality LoRa, the VAE, and the Clip H model all to their local versions, and I'll use FP8 wherever I can. The next 2 boxes represent the subjects in the video and the reference image respectively. We'll just write human, and at the very bottom pick a SAM3 matting model. Alright, all the red warnings are gone. Click Run. After about 2 minutes and change, we get the first 81 frame clip. After roughly the same amount of time again, the extension 81 frames are done too. Let's look at the result. The hand gesture dance follows the motion very naturally, the rhythm is captured nicely, and it's highly consistent with the driving video. The fox ears, hairstyle, and the details of the ancient-style outfit are all preserved really well, almost identical to the reference image. It's simple to use, but this workflow is a bit of a black box. Time to expand the nodes and tidy them up into this workflow. To make it easier to follow, we start from a version with only the first stage and gradually add features and compare parameters. This workflow can be broken into model loading, reference image, and driving video input, setting the prompt, mask material creation, character replacement versus motion transfer, sampling and scheduling, the final video composition, and the option to use accelerated mode on by default. The model loading part just chains the SCAIL-2 model, the DPO quality LoRa, and the Light X2V acceleration LoRa in series, with 2 wires pulled out before and after the acceleration model to support switching between full and accelerated modes. In the input source and preprocessing section, we upload the driving video and the reference image. The default width and height are 512x86, and they get processed to multiples of 32 through this formula. I'd suggest the final frame count should always match the driving video, set here in one place. We'll run 81 frames. The reference image will be center cropped to the target size using the area method, but you can also pick a different resize method based on your own reference image dimensions. The disabled group here toggles whether to disable acceleration. Since SCAIL-2 is a traditional derivative of the WAN series, it would be extremely slow without acceleration, so the Light X2V acceleration LoRa is used by default. The principle for the motion transfer prompt is to define the character's motion by combining the reference image and the driving video, but the final result can be fairly simple. The official example is just the girl is dancing. For character replacement, it needs to be much more complex, which we'll get to later. The negative prompt doesn't matter much. You can leave it blank, or, in non-accelerated mode, add a few quality prompts. The sampling part is nothing special. A standard accelerated config of 6 steps, CFG1, and the Euler plus simple combo. Like WanAnimate, the SCAIL-2 model doesn't directly read the driving video either, but it doesn't need to extract a pose control map. It needs a wider range mask, usually called a color mask, which tells the model which parts should be visible, marked in pure white, which shouldn't be, marked in pure black, and which characters are present, each in its assigned color. The parameters here are pretty important, so I've pulled them out into a separate workflow to demo and explain them. First is the max objects parameter. Since my driving video and reference image are relatively stable, I could set it to 1, but I'd still recommend keeping the default of 4. It's a parameter that's easy to misread. For example, if I switch to another single-person video with the same human prompt and this parameter is set to 1, in a lot of cases the second half of the video will fail to extract. That's because, to the model, max objects doesn't limit how many people you expect in the frame, but rather how many object slots the SAM3 detector is allowed to add in total across the whole video. The problem is that during tracking, the model will now and then misjudge things like clothing folds or hand edges as new objects and cram them in. Even though those misjudgments only last a frame or two before disappearing, the slots they took up don't come back. Once the slots are full, the model stops detecting entirely. It won't find new objects anymore, and it won't use the detection results to correct masks that have drifted, so you end up with no person visible. Set this parameter back to the default of 4, and the result is rock solid. Let's switch to a 2-person video and demo the other parameters. Click Run, and you can get masks for both people at once in different colors. The model will sort the masks it grabs based on the sort by parameter, assigning blue, red, green, magenta, cyan, and yellow in order. Right now it's left to right, so the person on the left is blue. Using this video as an example, I'll switch it to sort by area, and now the person on the right becomes blue. If you want to pick out one specific person among several, you do it with a semantic prompt. Let's change the prompt to the woman on the right, and run it again. Now only the right person's mask shows up. The detection node also has 2 parameters that control how often and how strictly, higher threshold meaning stricter, to look for new objects. Generally, the defaults are fine. The last parameter to watch is the mode. Because character replacement mode needs to keep the driving video's background, the mask is pure white, while motion transfer is pure black. Back to the earlier workflow, the option under the mask creation group controls whether the workflow does motion transfer or character replacement, and the group on the far right composes the final video. Click Run. We can quickly preview the masks for the driving video and the reference image. Since this is motion transfer and most of the final video's content comes from the reference image, it's on a white background, while the driving video is on a black background and only provides the motion driving. On an RTX 5080 it ran in 107.43 seconds, just under 2 minutes, and we got this 81-frame video pretty close to the version we ran before. The character's motion is smooth and natural, the waving and hard hand gestures are all clear, and the facial expression follows the driving video with subtle changes too. The SCAIL-2 considers their best resolutions to be 5112p and 704p. We just did 5112 by 896. But for better results, we naturally want to go up to 704p. Let's adjust to 704 by 1280 and run it again. This run took 254.7 seconds, just over 4 minutes, and the high-resolution bump is obvious. The hair strands, clothing texture, and finger edges are all much sharper. The facial lighting is more refined, and the fox ears' fluffy texture in particular looks great. The Ode to Joy hand gesture dance we just did was mostly upper body movement, which counts as a relatively simple driving video. Now let me switch to a 90,000 words video with push-pull camera movement. The video starts with a half-body framing and side-on motion, but the early action is still fairly mild, so I'll skip the first 340 frames and grab the part where the character leans in close to the camera to draw circles with her finger, then steps back to medium distance. For the reference image, I'll upload a frontal upper body close-up of a girl with curly hair in a white camisole. With WanAnimate, we often even had to redraw the driving video's first frame to generate the reference image, just to guarantee the final video quality. SCAIL-2 has improved a lot on this front. Since it's still a dance video, all the other parameters can stay exactly the same. Click Run. I'm really happy with how this video came out. The character's motion follows well, and the finger circle motion is smooth. The white camisole, curly hair, and gold earrings from the reference image are all preserved really well. The fingers do blur occasionally while drawing the circle, but honestly, for this kind of fast motion video, even real footage on short video platforms is about the same quality. If you swapped in a dance that emphasizes hand gestures over speed, the blur problem would be completely gone. I've also tested some videos with quite complex camera movement like this one. Doesn't it have a great street dance vibe? To really push SCAIL-2's motion following ability, we run a more complex hand gesture dance. This is the recently popular Me Do folk song, with lots of crossing, rotating, and rapidly switching hand gestures. Swap the reference image for a fresh, elegant girl too. Run it directly. The reference image is square, but the character is centered, so we can just keep the default auto-center crop. Since we swapped the reference image and driving video, we'll remake the mask material. In the looping workflow later on, we added a flow that detects and reuses materials, which saves the time of loading the SAM3 model and doing the matting. The final result looks like this. Pretty slick, right? Since demo time is limited, I only ran 81 frames here. Now let me play a longer version for you. Overall, the model follows complex hand gestures well, the two-handed crossing, palms together, and rotating motions are all smooth. The character's double braids, pearl necklace, blue and white checkered camisole, and white cardigan are all preserved really well, highly consistent with the reference image. The SCAIL-2 model doesn't rely on skeleton matching like WanAnimate does, so even when the reference image and driving video are very different, it can still transfer well. Let me swap the reference image for an anthropomorphic cute little rabbit and see if it can dance this hand gesture dance. Remember to change the prompt the SAM3 model uses to recognize the reference image to rabbit, and swap the positive prompt to the rabbit is dancing. You don't need to adjust anything else, the model adapts on its own. Click Run. Let's look at the result. This little rabbit's motion following is pretty good. The hand details don't quite look like real rabbit paws, but given that it's anthropomorphized, that's quite acceptable. Now try a pair with an even bigger gap. The driving video is a cute long-legged anime character dancing, and the reference image is a chubby, short-legged little white bear. Now go swap rabbit for bear in both prompts, but there's one thing that's a bit different here. The scarf on the bear in the reference image is fairly large. If the prompt only says bear, SAM3 will likely only generate a mask for the bear itself and miss the scarf. That might affect the final motion generation, so we need to write the prompt a bit more precisely. Just write bear wearing scarf. Click Run. Let's look at the result. This little white bear's motion following is done well. The waving, face covering, and hand-raising motions are all smooth. The fluffy texture, blue knit scarf, pink nose, and ears are all preserved really well, highly consistent with the reference image. But there's one not-so-obvious flaw. The first few frames of the driving video are completely blank, and the character jumps in from outside the frame. But this chubby little bear shows up in the video right at the start, then quickly disappears, and finally jumps back in. This phenomenon comes from the reference image and driving first frame being too different. You can boost the driving video's pose strength and tweak the prompt, or just re-roll a few times. After all, my driving video was itself successfully generated with SCAIL-2, and it performs perfectly. The rabbit and bear just now were still anthropomorphized. Now I'll just swap directly for a completely real cat. The driving video is the recently popular head-shaking dance. After the doll finishes a head shake, it wiggles its body. Let's see if the kitty can pull it off. Note that the prompt needs to be changed to cat everywhere. Click Run. This cat easily pulls off the left-right head swaying motion following. What's more impressive is that even though the cat's limb structure is different from the person in the driving video, it still clearly lifts a leg and wiggles its body. But if you want a cat in this form to do the dance the little white bear just did, it won't work. You'll easily get this six-legged effect. If you really want a real animal, like your own pet, to dance, it's best to first use an editing model to make it stand up, and then use SCAIL-2 for motion transfer. In the earlier WanAnimate tutorial, I showed how to replace a person in a specific position. You had to do that operation twice to achieve a full two-person replacement, but in SCAIL-2, it's much simpler, whether motion transfer or character replacement, multi-character is supported natively. Let's put on a driving video of two people covering their noses and dancing, paired with two standing kittens. The positions of the characters in the reference image and the video don't fully line up, only the count matches. Tweak the matting prompt for the SAM3 mask a little, change cat to cat in pajamas, which more reliably grabs these two anthropomorphized kittens. The max objects was changed to 1 earlier, so now bump it back up to 2. Honestly, just leaving it at 4 the whole time works fine too. Pay special attention to the sort rule. We want the characters in the reference image and the driving video to correspond 1-to-1. But using the default area sort isn't safe for multi-character. We need to switch it to a left-to-right position sort. The positive prompt changes from 1 cat dancing to 2. 2 cats are dancing. Honestly, with the reference image and driving video there, this sentence doesn't even need to change, but what can I say? I'm a perfectionist. Click Run. You can see the masks for both the driving video and the reference image have 2 characters, and both are blue on the left and red on the right. The model will find a way to assign the driving video's motion to the correspondingly colored character. The final result looks like this. The kitten on the left gets its face bumped by the one on the right, completely matching the driving video's motion. The only flaw is that a cup disappears, which you can fix by re-rolling. Motion transfer leans more toward generating new content based on the input motion, so the model has more room to play. Character replacement, on the other hand, is editing existing content. It has to keep the original video's scene, lighting, and motion while pulling off the replacement, so the demands on the model are extremely high. The SCAIL-2 model supports both modes. Everything we just demoed was motion transfer. Now let's try character replacement. Load the same single round workflow from before. Upload a revenge shake video with a forest path as the background as the driving video. In character replacement, the driving video is the original video being edited, and the reference image is a girl in a straw hat on a beach. Turn on character replacement mode. The matting prompts for both the driving video and the reference image are human. Character replacement, unlike motion transfer, does have some requirements for the positive prompt. The official docs give these 2 examples. The key is to describe the final frame, not the operation, ideally spelling out the character's appearance and the surrounding objects they're interacting with. To save some effort, I'll just go straight to the prompt enhancement plugin, the familiar me nodes, with the instruction woman is dancing, and click Run. By the way, I'll update the system prompt used by the plugin to the Fieshu doc, so anyone who isn't used to the plugin can grab it from the description. It ends up producing a prompt like this, mainly enriching a lot of detail on top of the original. Notice the generated masks opposite to motion transfer. The driving video uses a white background to keep the original scene, while the reference image uses a black background to ignore everything but the character. The finished video looks like this. The character replacement is very natural. The woman's straw hat, mint green dress, and pearl bracelet are all preserved really well, highly consistent with the reference image. The forest path in the background and the lighting all come from the driving video, and the stability is great with no flickering or warping. This counts as a perfect character replacement. It's as if the character was in this video to begin with. Let's add a bit of difficulty for the model and try swapping in a standing kitten. Note that all the prompts need to be changed to cat accordingly. The replacement result is quite good. The cat's smug little expression, plus that rhythmic motion really sells the nasty neighbor at the door vibe. On this basis, we can easily switch to a multi-character replacement flow. Just like with motion transfer earlier, adjust the max objects parameter. As long as the reference image and driving video mask colors line up, you can replace the corresponding characters like this cat boxing fight scene I ran. I'll skip demoing this simple case. What's trickier is if your driving video has multiple characters, but you only want to replace one of them. Since the SCAIL-2 model isn't an editing model, it can easily affect the other characters. The team knows this and might improve it in the future. In practice, if you want to keep the changes from spilling over, we need to mind a few details. Upload an MBTI comparison dance like this as the driving video. First, make sure the reference image is as close as possible to the driving video's first frame. For example, here I'm using the result of a first frame redraw. In the matting prompt, write the woman on the left. The prompt instruction is swap the person on the left for a specific anime character. Since this is the prompt enhancement node, it reads the driving video and reference image to generate it, so you can be a bit loose. If you're writing it by hand, describe the post-swap situation in detail, and remember not to write it as an edit command. Click Run. You can see the masks for the driving video and reference image are both accurate, only the left character. The final result is decent. The left character got swapped out with perfect motion, and the right character is almost indistinguishable, though the overall color tone shifted a bit, which you can fix in post. But even if you strictly follow this flow and observe all the caveats, if you want to swap the character on the right, not the leftmost one, the SCAIL-2 model will still most likely affect the other characters. For most videos with a static background, directly editing the first frame and then using motion transfer gives a more perfect result than character replacement. Let's not dwell on the single round flow. Now let me introduce a very practical looping flow. It can run a long video end to end by processing it in segments. Just load the workflow. I mentioned in my dedicated looping tutorial that the key to keeping consistency and continuity is letting each segment pull in as much info as possible from the previous segment for reference. Like WanAnimate, SCAIL-2 can take in the last few frames of the previous segment 5 by default and configurable. That way, the new round of sampling is much more likely to nail the result. But let me be upfront. After many rounds of looping sampling, consistency drift is hard to avoid, and so is gradual degradation. But fortunately, for most cases, it's good enough. This workflow is similar to what we demoed earlier. The added part is these two groups of loop nodes at the bottom. In there's not only a function to save materials and avoid remaking them, but also a design that uses local file caching to ease the pressure of merging long videos. It's complex overall, but you neither need to understand it nor modify it. When using the workflow, you only need to focus on these few groups in the top left. Upload the reference image and driving video, decide whether it's character replacement or motion transfer, pick the local models, and fill in the matting and positive prompts. By default, the system runs the whole video at 81 frames per segment and passes 5 frames between segments. These two parameters are adjustable too. For example, if you find 81 frames still too heavy, you can drop to 49 or even 33. If you have fewer segments and want better continuity between them, you can bump the 5 up to 11 or 13. Click Run. After about 12 minutes, we get this 17-second video.
I just wanna work it up to make you looked up, a must shut. Now you can see me in the shining star. Whoop, 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 whoop. Without a pain, you can reach the top. With it active, body they move so attractive. Look at your bossy, look at your bossy.
Overall, at this length, the degradation isn't obvious. From a consistency standpoint, the long, straight black hair, the white tube dress with ruffled trim, the 5 metal buttons on the chest, and the dark modern interior all stay unchanged, and the color curve transitions smoothly at every segment boundary. Being nitpicky, the character's skin does look a bit paler toward the end. Generally, this workflow can mindlessly crank out 1 to 2 minute videos. If it's any longer, the computer is under a lot of pressure when merging the video. I might find a way to optimize that later. But honestly, for a video that long, the consistency has already drifted into outer space, so it doesn't feel all that useful in practice. The official long video extension workflow adds color matching. Each round uses the tail frame of the previous segment as a reference to color tune the newly generated frames. In theory, this reduces the differences between segments and thus cuts down on accumulated color drift, but it's actually quite unstable. For example, if the previous segment's tail frame happens to be a high-key shot, then the entire subsequent video turns high-key too, so I removed that part from the loop. In its place is a standalone post-processing workflow. Just specify one image, the reference image, for example, upload the full video, and click Run. It'll color grade the whole video to match that image's tone. The result is pretty nice. Quite a few third-party plugins have popped up for the SCAIL-2 flow. They mostly focus on loop generation and on optimizing mask creation with multiple reference images, among other things. For example, Jeeg 9341 Lab, Comfy UI SCAIL-2, Easy Wukaka, Comfy UI WanAnimate Plus, FX Feho, Comfy UI Feho Toolbox, and Brobert in Oz Scale Auto Extend, among others. I tried these plugins out, and I found that for most people, the advantages they offer right now aren't obvious enough relative to the hassle of installing and using them, so I won't cover them individually in this tutorial. I'll keep an eye on them and maybe add them to a future all-in-one package. That wraps up the demo portion. Finally, let's summarize the SCAIL-2 model. It has undoubtedly replaced WanAnimate as the open-source ceiling for motion transfer and character replacement. The motion transfer is close to the level of closed-source commercial models, and with looping you can re-render minute-scale content. In my local 16 GB VRAM setup, I reserved 8 GB to simulate low VRAM. I really pushed it, and it still easily finished long videos, hitting 512 by 896 at 393 frames. The downsides are that after multiple loops, degradation is unavoidable. Consistency drift always creeps in, especially on pure white backgrounds, where artifacts show up easily. And since it's built on the WAN series of models, it runs slowly, the VRAM requirements aren't low enough, and it can't directly output video above 1080p. By the way, since LTX 2.3 came out, we haven't had a new open-source video generation model in a while. Bernini and SCAIL-2 and the like are all application-side solutions rather than model-side ones. Even though they've achieved nice results across different scenarios, they're constrained by the base model's capabilities and easily hit a ceiling. Alright, that's it for today's video. If you found this content helpful, please drop a like to show your support. All the models, plugins, and resource links mentioned in the video are in the description, so grab whatever you need. See you in the next one.